upside down and inside out. About to take your education on a brand new route. Because I'm Mr. Morrison, I'm here to say that it's time to teach math in a brand new way. Because if you think that your math ain't great, you're starting to hate, feel you can't relate. Well, if you know fool, be sure to stay tuned. There's a new way of learning flows into you, yeah.
Hello everyone, welcome to Algebra Made Simple. Today's topic, why so negative about negative numbers? We're talking about rules for calculating negative numbers. This has long been overdue, people. I've needed to talk about this subject for probably 10 years because I don't care what level it is. You can be talking 6th grade. You can be talking 7th and 8th grade. You can be talking calculus or trig or geometry. I can't tell you how many students struggle with understanding negative numbers in general, and most importantly, how to calculate them. I'm talking about when I multiply them, what happens if I add or subtract them, what happens, how do I handle them when I'm trying to solve an equation. It just gets them all twisted and confused, and it can really lead to inaccurate results. You know, if you're trying to make a bridge, it might lead to people dying if you don't get the numbers right and the weights right. And listen, we got to talk about this thing. So hopefully this will bring some clarity to students who are struggling. In particular, I have a few that I'm thinking of that the negative number issue is getting us in trouble as far as how to calculate them. So I just want to go over some rules, okay? So rule number one, I'll try to put some graphics up when I do this video, but rule number one, you need to understand there's a different set of rules when you're multiplying or dividing numbers versus if you're, say, adding and subtracting or subtracting them, okay? So let's talk about multiplying and dividing first. First off, when you're multiplying or dividing, okay, both are kind of together when it comes to this rule. When you're multiplying or dividing, opposite signs lead to negative outcomes. Opposite signs are always negative numbers. For example, let's just go over some basics here. Let's say I had the numbers, I don't know, let's do -3 times a +5, and I'm trying to figure out what that equals. Can you see that? See how you have opposite signs? One's a negative, one's a positive. Well, opposite signs lead to negative outcomes. So that's going to not be 15. It's going to be a -15. And by the way, students, 15 and -15 are very different numbers. Ask your parents if they have $300 in their checking account versus -$300 in their checking account, if that's the same situation. Oh, you're going to find out real quick, and they're going to tell you real quick with some passion in their eyes, it's not the same thing. So yes, the negative sign does matter, okay? Now, if you have another situation where it's the opposite, let's say it's division, all right? Let's say you had, I don't know, 30 divided by a -3, for example. Take a look at that. See, in a lot of times in algebra especially, you'll start to see division written more like a fraction, the top number being divided by the bottom number. They're still opposite signs, so that's going to be a -10, not a +10, right? Okay, so say you understand that, all right? When you're multiplying or dividing, if they're opposite signs, they're negative. That means if they're the same sign, they're positive, okay? If opposite signs are negative, that means if they're the same sign, it's always going to equal a positive. That's why a -3 times a -5 is a +15, or a -30 divided by a -3 is a +10, okay? So this is something we need to get clear. Now, that is not the same story. It's really not the same set of rules if you're dealing with addition or subtraction, okay? Addition and subtraction go together just like multiplication and division go together. So with addition or subtraction, there's kind of a different way you got to look at it. I always tell people this. If the signs are opposite, let's say you have a, I don't know, addition, subtraction situation. I'll give you one like this. Let's say you had a -10 plus 4. This is where some people just, for some reason, their brains just completely get confused here, okay? You have to ask yourself, am I multiplying or dividing or adding and subtracting? Okay, you could kind of you would definitely put this in the adding or subtracting column, right? In other words, you got a negative number, -10, but you're adding 4 to it, right? So what you'll notice is the signs are just practically opposite if you look at there, all right? You got a -10 and a +4. If the signs are opposite, basically subtract the physical numbers from each other and go with the sign of the bigger number. So for example, if I see a -10 and a +4, the signs are opposite. I'm taking the difference. So just look at the 10 and the 4. 10 minus 4 is 6. I know that that's the case. But because 10 is a bigger number than 4 and 10 is a negative number, I'm going to make sure my answer is negative. So it's really going to be -6. Do you see how that works? All right, you see how that works? So this is where a lot of people get into trouble. Sometimes if you're a parent, for example, and you're trying to get this concept to your kid, it helps to use money. I don't know why with human beings with money, all of a sudden people can pay attention and concentrate. If you don't use money, good luck. But let's say you tell your kid, like, hey, what happens if you had to borrow $10 from your buddy Bob, right? Bob, can I have $10? Okay, you owe him $10. The next day you pay him $4. How much do you still owe him? Well, you owe him $6. A lot of kids don't have trouble understanding that. So when you say owe, put a minus sign there, and sometimes that brings some clarity. But anyway, I have the rules written up, and we're going to go through some examples, both with the just normal situations with numbers, but then also with equation solving. I thought would be worth our time. So let's go ahead and get into it, and I'll try to put the graphics up so you guys can see this as well. Okay, so take a look right here. I put the rules in red because I want kids getting used to, while they're learning these rules, or if they're struggling with these rules, to just be like, hey, I have to look at the rules before I make a decision. Okay, so if you take a look at something simple like this, you have 2 plus 1. I'm going to go ahead and just put my pencil icon in here so I can draw. You got 2 plus a negative 1, excuse me, right? And so you got to ask yourself before you get started, I'm looking at number 1 right here, is this a multiply or divide situation, or an add and subtract situation? Let's give it some time. Oh, hopefully you said, oh, Chris, that's an add and subtract situation. Okay, well, then are the signs the same, or are they opposite from one another? Let's take a good look at that. Let's see, positive 2, negative 1. They look like they're opposite signs. If they're opposite signs, you basically are doing the difference, or subtracting. 2 minus 1, of course, would be 1. And the sign of the bigger number, let's see, 2 is bigger than 1, 2 is positive. So I'm going to leave this as a positive 1. See how simple that can be when you think of it this way? Follow the rules. Now, if you go down a little bit lower, let's say we skip number 2 for a sample, and we're going to go to number 3 here. Hopefully you can see that all right. In fact, I might just zoom that sucker in so you can see it a lot better, okay? Take a look at number 3 right there. I'm going to underline it. You got 1 minus 4. Well, 1 is positive, minus 4 you could say is negative. They're opposite signs, right? Well, let's take the difference. The difference between 1 and 4. 4 take away 1, right? That would be 3. But notice this time 4 has that minus sign in front of it. 4 is bigger than 1, so I'm going to make sure I say that that's a negative 3. Does that make sense? Now, while we're on this subject, I want to take a look at numbers 4 and numbers 5, because they're definitely a little different. If you look at number 4 right here next, you have a negative 4 plus a negative 5. And you have to ask yourself, am I multiplying, dividing, adding, or subtracting? Well, once again, I'm adding and subtracting. Well, same sign, add the numbers and keep the sign of the, keep the signs the same. So if they're both negative, negative 4 plus negative 5, add the numbers. 4 plus 5 is 9. They're both negative, so you keep the sign of both of them. I am done. All right? So that's just one thing. Now, this isn't in my rules, but hopefully you've been around the block long enough to hear this. If you haven't, listen to me now. Number 5 is what I want to get at next. You see how it's saying 6 minus a negative, double negative? If you haven't heard it before, you need to understand. If you subtract the negative, that's essentially a negative times a negative, which means a positive. In other words, that's the same thing as plus 1. If you take away a negative, you're really adding. Okay, double negatives make it a positive. So this isn't 5 like some people are going to think. It's really equal to 7. And think about real life for just a second, okay? Think about it. Let me just put it to you this way. If someone in your life is really a frenemy, let's say you have a group of friends, there's 4 of you, and then one of them is just really a jerk, and you're starting to realize, you know what, this person isn't really my friend. They're a negative person. They always start gossip and strife, and whenever they're gone, we have a whole lot more fun than when this person's here. So you could say, when I take away the negative person, my life gets better, right? To take away a negative is really, at the end of the day, and get rid of that light, it's getting a little blurry. To take away a negative is really adding to your life. It's a positive. It's a plus to your life, right? Taking away a negative in math, it's a lot the same way. So when I take away a negative, that's going to definitely be a positive in my life. So going back to the screen so you can see that. Double negatives, that's a positive. See what I'm saying? Okay. So with that being said, I'm going to scroll down a little bit here so we can get to some situations where hopefully we got some multiplication. There it is. So in this situation, notice that these are all multiplication. So if it's multiplication, go back to here. It says multiplying means same sign positive, opposite signs negative. Same sign positive, opposite signs negative. I'm going to say it again. Same sign positive, opposite signs negative. So if you look at number 21 here, 2 times a negative 4. 2 times a negative 2. I don't know where the 4 came from. Are those the same sign or opposite signs? 2, positive 2, negative. Oh, those are opposite signs. Opposite signs equal negative answers. So that's going to be a negative 4. If you look at number 22, they're the same sign. You got negative 8 times a negative 5. Same sign is always a positive answer. So 8 times 5 is 40. So I'm going to leave it as positive 40. And so on and so forth. Okay? So hopefully that's making some sense to you. Same thing with quotients, all right? Quotients mean division. It's a division situation. So division situations are exactly, as far as the negative rule is, the same as multiplication. If they're opposite signs, such as negative 72 divided by a positive 9, they're opposite signs. My answer's got to be negative. Opposite signs are negative, but 72 divided by 9 is 8, so that's going to be a negative 8. We got to get this right, y'all. Same thing, number 32. A negative divided by negative. Those are same signs. So 35 divided by 7 is 5, and it's got to be a positive 5 because same signs are positive. Okay, so watch this video as many times as you need to get clarity on that. All right, so the next thing I want to do real quick, that's just going over some real basics. It's one thing to do it when you're just given the numbers. It's another thing to do it in the context of what we call equation solving. So when you get to pre-algebra, algebra 1, that's the first time you're really wrestling with trying to solve for x, trying to solve for this variable. We want to know what it equals. And you have to deal with negative numbers quite a bit. So I want to look at some examples in that context. Let's go back to the page here, and I have another tab I want to click on. This is, once again, the same kind of rules, and I'm going to bring this up. I already put it up here before the video, so you guys can kind of see this in action. And what I want to do is look at a couple situations here where I've seen kids get confused in the past. I want to start with number 3 just because of the nature of it with these negative numbers, okay? So if you look at number 3, I'll just go ahead and turn on the pencil icon. Number 3, you try to solve this. This is a two-step equation. If you're taking Algebra 1, you probably heard you have to do what's called an inverse operation or opposite operations to solve. If this says 3p minus 2, the way you solve it is to do the opposite or the inverse of what's happening. If it says minus 2, the opposite would be to plus 2, right? So we would add 2. What you do to one side, you do to the other. This is how you would solve a two-step equation normally, right? Well, negative 2 plus 2 cancels out. You bring down what's left. Uh-oh, had a little glitch there. Let's try that again. That would be 3p equals, and then we have to figure out, this is where a lot of kids get in trouble, y'all. It's negative 29 plus 2. Well, is this a multiply-divide situation or an add and subtract situation? Ding, 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 ding. It's add or subtract, people. Okay, why? Because it says plus 2. It doesn't say times 2. So since it's an add or subtract situation, I got to ask myself, are those the same sign or opposite signs? Well, the 29 is negative, the 2 is positive, they're opposites. That says subtract the numbers, keep the sign of the bigger number. Well, 29 take away 2 is 27, and since 29 is bigger than 2 and 29 was negative, make sure my answer is negative. So that would be a negative 27. A lot of kids are going to get a lot further and get some clarity today because they paid attention to this one issue that's holding you back. It's not that you don't know what steps to do. It's that somehow in your head you get confused and stuck. At this point, I'm trying to bring clarity. Of course, you got to then solve it. Of course, you divide by 3 on both sides. That's the opposite of multiplication, so that's what you do. And once again, now we're dividing, all right? You look at the situation for dividing and multiplying, right? You got negative 27 divided by a positive 3. They're opposite signs. Opposite signs equal what? Negative 27 divided by 3. I'm looking right here in case y'all are wondering and watching the video. Opposite signs are always equal to, hopefully you're seeing it, a negative. They equal negative. So we know it's going to be negative something. 27 divided by 3, of course, is 9. So in this situation, P is equal to negative 9. Okay? So I'm going to leave that one right there because I want to look at number 4. Number 4 is almost deceptive in some ways because the way it's laid out, it can be confusing for folks. But take a look at number 4 for a minute. You got positive 1 minus r equals a negative 5. Well, you have to do the inverse, but you want to start with the part that's not next to the variable. In this case, it's a positive 1. Well, the inverse of positive is to subtract, and this is how I'd start this if I'm doing an inverse operation. Now, negative r, I'm going to bring down, and watch it now. Sorry for the glitch there. You got negative 5 minus 1. Well, this is, of course, is an adding or subtracting situation. It's not division. It's not multiplication. If the signs are the same with adding and subtracting, it says that you add the numbers up and keep the same sign, right? So zooming back in here, negative 5 minus 1, they're the same sign, so you add up the numbers. 5 plus 1 is 6, but since they're both negative, we call it a negative 6. You with me? Now, one other thing that can be confusing for some kids, and I'm going to point this out now, is you're not allowed to leave your answers as negative. You can't say negative x equals this, or negative r equals negative 6. Remember, a negative r is the same thing as a negative 1r. I'm a big fan of just penciling in a 1 whenever there's a negative variable. And so you'll see that that's negative 1 times r, technically, if you've been taught correctly. Anytime you got a number right next to a letter, it's being multiplied. The inverse of multiplication, which is what we have to do, is division. So we're under this situation where we're now dividing, and you're dividing two negative numbers. So we have to go to the rule. Let's go back to the rule. Let me zoom out so you can see that. Multiplying or dividing is the rule we're using here. Negative 6 divided by negative 1. Well, are they opposite signs or are they the same sign? Let's see. Negative 1 divided by negative 6 divided by negative 1. They're the same sign, Chris. You're right. So if they're the same sign, that means they always equal a positive. And 6 divided by 1 is 6. And so I know r is equal to a positive 6, not a negative 6, a positive 6. So if you need to, and if you're watching this video, I'm going to just take some time real quick. Let me rewind this thing on back. I'm going to zoom in if it'll let me. Well, it might not let me, folks. Here we go. I'm going to zoom in if it'll let me and just take a nice screenshot of this set of rules. This should help a lot of people today. Just study it, take a screenshot, look at it, take it in. If you're multiplying or dividing, same signs will always equal positive answers. If they're opposite signs, they will equal negative answers. These are facts you just have to know, right? Add or subtracting is a different set of rules. The same sign means just add the physical numbers up and keep the sign. Okay, everything's negative, so keep everything negative. Negative 2 minus 1, hey, negative 3, keep everything negative. But if they're opposite signs, you're really subtracting the difference between those numbers, right? But you want to keep the sign of whatever number is physically larger. Okay, so hopefully this brings some clarity to a point, stuck point for you that's given you a lot of frustration and confusion in the past. I've just seen it with so many of my kids. Some people have no problem with negative numbers. Some students never struggle with it. They learn the rules once in class and they can put it into action, no problem. It sticks great. Some kids, it's just a weak point for them. So this video, the purpose of it is to help you for those kids who just struggle with that one area and it's leading to incorrect calculations when you're taking your quizzes, your tests, your standardized assessments, maybe scholarship money's on the line, I don't know, and this has just been a thorn in the side. I'm hoping that this can give you some clarity. So let me know in the comments if this is you're negative about negative numbers. Why so negative? You don't have to be so negative about it. This is the rules, or these are the rules for calculating negative numbers. And my wife told me to do this, so I'm going to do it. A few years ago, maybe 6-7 years ago, I can't remember. I was teaching at a school, inner city school, and there's a group of girls. If you see this video, you know who you are. And y'all had this song y'all came up with to help you guys with negative numbers. And y'all just thought it was hilarious. It was about a group of 3 or 4 of them. And so I'm going to try to sing the song in honor of you guys because this is just what I do. It entertains me. Maybe it'll entertain you. They went like this. They went negative, 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 and they would just do that every time there was a negative number. You know who you are. Sorry, maybe I embarrassed myself. Don't really care. I thought it was worth it. Negative, negative. Why so negative? Okay, don't be negative about negative numbers. These are the rules for calculating them. Hopefully this helps. I'll catch you guys on the next one. Have a great day. Peace.
Upside down and inside out, about to take your education on a brand new route. Because I'm Mr. Morrison, I'm here to say that it's time to teach math in a brand new way. Because if you think that your math ain't great, you're starting to hate, feel you can't relate. Well, if you know fool, be sure to stay tuned. There's a new way of learning flows into you, yeah.